Up next, we're going to be looking at trapezoids and kites. So let's start with our first type of trapezoid, the regular old trapezoid. When you're talking about trapezoids, there's one thing that's going to be true, and or two things are going to be true. That's that you have one pair of opposite parallel sides, so that would be this one and this one. And then the other thing that's going to be true is none of the sides are going to be the same length in a regular old trapezoid. So this, and this are all different lengths. Now, we do have names for each of these sides. We're going to call this a leg, and we're going to call this a leg. This is going to be a base, and this is also going to be a base. So then this is a set of base angles, and then this would also be a set of base angles. Now, the thing is that none of these are actually going to be the same measure. We just know that if we're talking about this base here, then it has a pair of base angles. If we're talking about this base here, then it also has a pair of base angles. The next set of trapezoids we're going to look at are called isosceles trapezoids. And the reason why they're called isosceles trapezoids is because they actually are going to have the legs are going to be congruent. So we know that this leg is going to be congruent to this leg here. Then our base angles are also going to be congruent in isosceles trapezoids. So we know that that angle will be congruent to that angle, and that angle will be congruent to that angle. Now, if you were to take an isosceles trapezoid and continue the legs up, they would actually meet somewhere up there to create an isosceles triangle. So what you want to remember about isosceles trapezoids is, again, you've got one pair of sides, the bases are going to be parallel, but then the legs are going to be congruent to each other. The base angles are also going to be congruent to each other. For problem number 1, we're given that quadrilateral CDEF is an isosceles trapezoid. And what we want to do is figure out what are the measures of angles D, E, and F, given that C is equal to 65 degrees. So let's start with the easiest one. Since C is a base angle with angle F, we know that they have to be congruent. So if angle C is 65 degrees, then that means that angle F also has to be 65 degrees. Now remember that the isosceles trapezoid is a quadrilateral. So the sum of the interior angle measures is going to be 360. So if the entire thing is 360, then what we've already figured out is that we've got a 65 here and a 65 here. So we've already eliminated 130 of those degrees. So we're going to subtract 130 from 360. That's going to give us 230. What that means is that we're going to split those remaining 230 degrees equally between angles D and angle E. So if we do that, if we divide 230 by 2, that gives us 115 degrees. So that tells us that angle D has to be 115 degrees and angle E has to be 115 degrees. Now the other way that you could get this, or the way you could check this, is you know that segment DE is parallel to segment CF. That means that segment CD is a transversal of those parallel lines, which means that these two are same side interior angles, and same side interior angles add to 180. 115 plus 65 is 180 degrees, so we know that our measures for D, E, and F are all the correct measures. For problem number 2, we've been told that this fan has been broken into 20 separate equal slices, and we're asked to find the values of both X and Y. So what we want to do with this is we want to figure out how many degrees is that angle where these two lines come together at the center. So to do that, we've got to figure how many degrees are there in a circle. There's 360. And if you're taking 360 degrees and dividing it equally by 20, we're going to do 360 divided by 20, which is going to give us 18 degrees. So this angle right here is going to be an 18-degree angle. Now that's going to be important because what we can do is we can take this piece right here and we can say that is an isosceles triangle. So if we have an isosceles triangle and the vertex angle is 18 degrees, then we can very easily figure out what are the other degree measures of the other two angles. Since this is an isosceles triangle, what we're going to do is 180 minus 18, which is going to give us 162, and then divide that by 2 for these two angles. So then we have 81 degrees here and 81 degrees there. Now if we continue drawing out the isosceles trapezoid, which is below it, we find that here's angle Y and here's angle X. Well, angle X is actually very, very simple to figure out because we know that this line has to be parallel to that line, which means that these are corresponding angles. So we know that X is equal to 81 degrees. Y is even easier to figure out because Y is paired up with this 81 degrees here and then make a linear pair. So if they're a linear pair, it's simply going to be 180 minus 81 is going to give you Y. So 180 minus 81 is 99 degrees. So X is 81 degrees and Y is 99 degrees. Up next we have the trapezoid mid-segment theorem. So this is actually not too difficult of a concept to understand. If you've got a trapezoid and you find the midpoint of each of the legs of the trapezoid, and then you connect them together, then you've got the mid-segment of the trapezoid. It's the same thing that we did when we did the mid-segment of an isosceles triangle, or the mid-segment of a triangle. So you just find the midpoints of each of the legs connected together with the mid-segment. Now that has a special relationship with the base 1 and base 2. It's going to be the average of those things. So if you remember how to calculate average, you just add up everything and then divide by the total number. So with this, what we're going to do is we're going to take the mid-segment is going to be equal to base 1 plus base 2 divided by 2. We're dividing by 2 because there's two bases. So we're going to apply that here down in problem number 3. In problem number 3, we've got a mid-segment OR that is given the value of x plus 2. The base is 4x minus 10, and the second base is 8. So what we're going to do is use this formula and just plug in what we need to plug in. So our mid-segment is x plus 2. That's going to be equal to the sum of the two bases. So 4x minus 10 plus 8, and then we're going to divide that result by 2. So a couple of ways you can do this. I'm going to go ahead and get rid of that 2 in the denominator so that I'm only working with one string of numbers. So to do that, I have to multiply both sides by 2. When I multiply both sides by 2, these 2's cancel out, and I distribute this 2. So 2x plus 4 is equal to 4x, and then I'm going to go ahead and combine the negative 10 and the positive 8 to get 4x minus 2. Now it's just simply finding x. Move the 2x over because that's the smaller coefficient. So 2x minus 2 is equal to 4. Add 2, so 6 is equal to 2x, and so x is equal to 3. So now if I plug this in, I should be able to find both the mid-segment and the base 1. Base 1, 4 times 3 is 12, minus 10 is 2, and then 3 plus 2 is 5. If I add up this base and then divide by 2, I should get the mid-segment. So 2 plus 8 is 10, divided by 2 is 5, and 5 is what we found for our mid-segment. So we know that our x's are correct, and we know that our bases are correct. The last kind of quadrilateral that we're going to take a look at is called a kite, and you should be familiar with these, especially if you were a kid and went out and flew a kite at some point. So a kite is going to look like this. What it's going to have is consecutive sides are going to be congruent. So those two sides are going to be congruent, and then these two sides are going to be congruent. Now what that's going to do is it's going to create an isosceles triangle on the left side and an isosceles triangle on the right side. So we know that this angle is congruent to this angle, and this angle is congruent to this angle. We also know that this angle here is going to be congruent to this angle, and this angle down here is going to be congruent to that angle there. Now, the diagonals are also going to have a couple of special properties. The diagonals, they're not necessarily going to bisect each other, but they are going to intersect at right angles. Now, the longer diagonal is actually going to bisect the shorter diagonal. So this one right here is going to be congruent to that one right there. And those are your properties for a kite. For problem number 4, we're given a kite and we're asked to find some angles on that kite. So we're given 52 degrees for this angle here, and we're asked to find the intersection of the diagonals, the angle that's out here on the top right triangle, and the top angle of the top left right triangle. So let's start with angle number 1. Angle number 1 is perhaps the easiest one because we know that the intersection of the diagonals of a kite are going to meet at 90-degree angles. So we can go ahead and call that 90 degrees. Now, I'm going to go ahead and fill in 90 degrees right there, and what you can see here is we now have a right triangle. So remember that a triangle has 180 degrees, so we're going to add up the degree measures that we know. 90 plus 52 is 142, and then we're going to subtract that 142 from 180, and that's going to leave us with 38 degrees for angle number 2. Then the last angle measure that it's asking for is angle number 3. Now, since we know that this angle here is congruent to this angle here, we know that angle number 3 also has to be 52 degrees, and that's going to be your solution to your problem. Okay, to sum up this chapter, what we're going to do is take a look at the relationships between each of these different types of quadrilaterals. Every single one of these shapes right here qualifies as a quadrilateral. So we can say that a square is a quadrilateral, we can say that an isosceles trapezoid is a quadrilateral, we can say that a kite is a quadrilateral. But we can't say that every quadrilateral is a kite, an isosceles trapezoid, or a square. In order to be one of those, it has to meet certain conditions. The only condition for a quadrilateral is that it has to be four-sided. Now, a square is always going to be a rhombus or a rectangle, and it's also always going to be a parallelogram or a quadrilateral, but not every rectangle is a square, not every rhombus is a square. Not every parallelogram is a rectangle, not every parallelogram is a rhombus. Parallelograms that want to be rhombuses or rectangles have to meet certain conditions. But every parallelogram is a quadrilateral. Every isosceles trapezoid is a trapezoid, but not every trapezoid is an isosceles trapezoid. In order to be an isosceles trapezoid, it has to meet certain conditions. It's akin to saying that your thumb is a finger, but not every finger is a thumb. Your thumb has certain characteristics that your other fingers don't have. In the same way, squares have certain characteristics that everything above it doesn't have.